Correlation is one of the most useful statistical analysis to see the relationship between two simultaneously occurring events. See, it deals with the association between two or more variables. If two or more events vary in sympathy, then they are said to be correlated. And one of the variable is considered to be independent and the other one dependent. See, we are able to judge that which variable is independent and which one shows dependency. Now we can see that this correlation could be of four different types, like positive correlation, when both variables deviate in the same direction. That is, increase in one variable results increase in the other one. The second one is negative correlation, in which the two variables deviate in opposite directions. And the third one is linear correlation, where rate of change in two variables are same. And the fourth type could be non-linear or curvilinear correlation, when one variable increases at a constant rate while the other increases irregularly. See, in this diagram, in the first graph, the independent variables are shown on the x-axis, whereas the dependent one is depicted on the y-axis. And the figures are actually put over here, and we can see the direction of occurrence. Now here there is positive correlation because there is constant increase in the different variables. Means if there is increase in the x variable, it also results increase in the other variable. In case of negative correlation, there is increase in one variable while decrease in the other variable, that is dependent one. So in that case you find the negative correlation. And in case of no correlation, the different values are randomly scattered, so the correlation will be exactly zero. Now, positive correlation may be observed between heights and weights of school-going children. We find that school-going children, they experience increase in their height, and that also results into increase in their weight. So there will be positive correlation in such situations. The increase in the yield of a commodity may be associated with an increase in its consumption. So here also you can see positive correlation. The third example could be the decrease in the price of a commodity may be associated with an increase in its production. So there will be negative correlation. And the correlation between age and playing habit may be negative. That is, with increasing age, the interest for playing that goes on diminishing. So these are some of the examples which could be used to understand the relationship between two happenings, between two events which are related to each other. Now we can see the extent of correlation, that is, the correlation could be positive or it could be negative, and we say perfect correlation when the value comes exactly 1, because correlation coefficient, which is indicated by R, that ranges from 0 to +1 and also 0 to -1. So there will be perfect correlation if this value comes +1, and if it comes -1, then there is perfect negative correlation. And if the values come between 0.75 to 0.99, then there is very high level of correlation between the two happenings. And if the value comes between 0.75 to 0.99, then there is negative correlation. So if this value comes in negative and it is between minus 0.75 to minus 0.99, then there is very high level of negative correlation. Now we say moderate correlation when the values range between 0.25 to 0.75. So this will be positive moderate correlation, and if the values are between minus 0.25 to minus 0.75, then there would be moderate negative correlation. And low level of correlation would be there if the value is in positive but it is below 0.25, and if it is less than 0.25 but the symbol is in negative, then there is low negative correlation, and there would be no correlation if the value comes 0. The formula which is used to solve correlation coefficient is quite simple, and several modifications of this formula could be seen, but most convenient one I am showing here, that is this R is equal to sum of xy minus sum of x into sum of y divided by n, and this whole will be divided by square root sum of x square minus sum of x its whole square divided by n into sum of y square minus sum of y its square divided by n. We can have complete idea about the utility of this formula by considering a particular example. So here I have shown the length of thorax and abdomen in a particular insect species. Suppose there is an insect species and we are measuring the length of its thorax and abdomen, and we randomly selected 1, 2, 3, 4, 5, means 5 insects have been considered. Their thoracic length comes 2 mm and the abdominal length of that insect comes 4. Then the other insect shows its thoracic length 3 mm while its abdominal length is 6 mm. Then the third insect, its thoracic length is 5 mm and its abdominal length is 9 mm. Then the fourth one, its thoracic length is 8 mm while its abdominal length is 11, and the fifth insect, its thoracic length is 7 mm while its abdominal length is 11 mm. So this is data, and we want to see whether there is any correlation between thoracic and abdominal length. Now what we do, we can consider the sum of x values and also sum of y values, and we need x square, y square and xy, means sum of x square, sum of y square and sum of xy. So how all such things will be done and how this R value or correlation coefficient could be calculated, that we can see in further slides. Now what is shown here, that x variables are shown here in this column, that is the length of thorax in millimeter is shown in the first column, then length of abdomen is shown in the second column, that is y variables are here, and we have taken sum of x, that has come 25, sum of y, it has come 41. We also need sum of x square, sum of y square and sum of xy. So what we are doing in the third column, we are getting x square, that is each value of x will be square. So 2 2s are 4, 3 3s are 9, 5 5s are 25, 8 8s are 64, 7 7s are 49. So we have squared all these values of x and its sum has come 151. Likewise, the values of y will be squared. So these are the values of individual square values of y variable, and its sum has come, sum of y square, it has come 375. And then in the fifth column, we are obtaining sum of xy. For that, we shall be multiplying the values of x and y. So 2 into 4, it has come 8. Then 3 into 6, it has come 18. 9 into 5, it has come 45. So that way, we have got the values of xy for each case. Its sum has come 236. Now what we are doing, we have to simply put the values of sum of x, sum of y, sum of x square, sum of y square, and sum of xy in this formula. So here sum of xy will be written, it will be 236 minus sum of x, it is 25, into 41 because it is sum of y, divided by 5 because 5 variables are there. Means 5 individual cases have been considered. And divided by square root sum of x square, so this value is 151. Then sum of y square, this value is 375. So we have to simply put these values in the formula to obtain the final correlation coefficient. This is actually Pearson's correlation coefficient because this is one of the popular methods to calculate correlation. Now here simply the values have been put in the formula. 236 is actually sum of xy minus 25 into 41, that is sum of x and sum of y. These two values have been multiplied and they are divided by the total number of observations, that is 5. And this whole is divided by square root 151, that is sum of x square minus 25 its square divided by 5 into 375, that is sum of y square minus 41 its square divided by 5. And when we will solve this, the value of r will come 0.98. After this, we can see whether this value is significantly more than the 0 or there is insignificant difference. For this purpose, we can see a table where the values of r at the level of 0.05 and 0.01 will be given. So this table indicates values of r for the 5% and 1% level of significance. Here the degree of freedom will be n minus 2. In the present case, there are 5 observations, so degree of freedom will be 3. And at 3 degree of freedom, if the r value is 0.878, then we will be considering that there is significant positive correlation. R means you can consider whether the relationship is significant or not, whether it is positive or negative, and you can also see the value at 0.01 level. So since our value is 0.97 or 98, so we consider there is significant positive correlation. So here degree of freedom is shown, that is 3, and probability level is less than 0.01. So we actually reject the hypothesis that there is significant positive correlation between thoracic and abdominal length. So this is one of the convenient methods of calculating correlation coefficient.